Hello, everyone. Hope you're doing okay. A few emails from people that they've gone into quarantine, so I bet you all know some people who are in quarantine. So touch wood for the next week or so to see how we go. Anyway, so last time we introduced the idea of the second derivative. So now you should have in your mind the idea of a function. Right? A function is just a rule, and it's just some quantity. Then we have the derivative of that quantity. This is the function, it's the quantity. F prime, that's the rate of change of that quantity. Right? It's positive if it's increasing, or positive if it's a positive slope, an increasing slope. And then we have the second derivative, and that's the derivative of the derivative. And that gives kind of like the acceleration of the quantity. And it tells us things like, are things speeding up? What is the concavity of the graph? Okay, so here's a simple problem. So here you've got B, C, D. I've got 4 points there. So what can you tell me about F at those 4 points? Are they positive or negative or zero? They're all positive, right? They're all, F is the quantity, and we know whether a quantity is positive if it's above the x-axis. So all these things are positive. Okay. What about the derivative? Which of those points have positive derivative? Michael, what do you think? Where are the Michael, Matt? Your twins, Michael, right? Okay. He doesn't know what he's taking the class. So Matt, where are we positive slope?
A and D.
A and D, exactly. What do you think's happening at B?
Constant.
Hmm?
So is it constant at 0?
Yeah, it looks like it's constant. So at B it would be 0. So what's happening at C?
Negative.
Negative. Exactly. Okay. What about the second derivative? Where do we see some positive second derivative? Ellie, what do you think?
Wouldn't D be positive? And C and D wouldn't be positive?
C and D, yeah. C, yeah, probably. Yeah, because maybe, yeah, it looks like it's just positive. So C and D look like they're positive. And how could you tell that?
Because it's concave up.
Exactly. And so what's happening at A and B?
It's concave down.
So it's negative. Exactly. Okay, so this is kind of what you should know. So that's good. Okay, so this is going to be a common question, particularly in the first half of the semester, is do you know the difference between F prime and F double prime? And this example here, if you understand this example, that's going to get you some points in the exam. Okay, great. Let's get rid of this. Okay, so let's today we're going to look at some economics. So economics for us is just going to be a constant source of examples. So once we've learned stuff, we're going to have a look at economics and just have a look at a couple of applications and see if what we've learned can give us some kind of practical understanding of what happens in economics. Okay, so so let's have a look at our cost function. It's going to work here. So when we first looked at cost, our simple example that I think I gave in homework was the idea we have a linear cost. So cost would look something like this. Okay, and so it's a straight line. So there's two things to know about a straight line. It's intercept and its slope. Anyone remember what the intercept was? The intercept means something when we're talking about costs. It's the fixed cost, exactly. And that's a typical kind of thing that an intercept means. An intercept, and the y-intercept means what is happening if the input is nothing. And so that's going to be something which is kind of fixed. No matter what the input is, it's always there. What does the slope tell us? Anyone remember?
Variable cost, like how much is added for each one.
Right, because what are the units? So if cost is in dollars and Q is in units, slope, the unit of slope is dollars per unit. Okay, so that is kind of like the variable cost. Now we had a look and we thought, well, in reality, things aren't always such a straight line, and maybe it'll look something more like this. And I thought it shouldn't have gone down. Yeah, maybe something more like that. So again, cost is in dollars, and the axis down there, we've got things in terms of quantity. What is this intercept? What is that still? It's still fixed cost, right? Because it's still what is the cost when the input is nothing, when we're doing no cost, no manufacturing or. It's still the fixed costs. We still have a slope, and it's still going to be dollars per unit. And we can think of that as the variable cost, but what do we see about the variable cost? It actually varies, right? So usually here when we're talking about variable cost, the only thing that's varying is Q. That's why it's called variable cost. Here, it's changing not only as Q is, not only with Q, but the actual amount of it is changing depending on what Q is. So it really is varying. So instead of variable cost, we're going to call that marginal cost. And we call it marginal cost because we want to think of it not as the slope of a straight line, although we know that really deep down that's what lies underneath the math of it. We're calling it a marginal cost because at different Qs, at different output from our factory, the cost of producing the next unit is going to change over time. Okay? So here, so remember here we're seeing the benefits of economies of scale. So we're seeing that the marginal cost is decreasing. And then if we produce so much, the marginal cost starts to increase again. And that's because, we have to build new factories, hire more workers, we have to do stuff. We haven't got enough materials to make our goods, we have to go out and we have to try and get more, and so costs are going to go up. So marginal cost, this is the same thing as the derivative of the cost function. And we can also call that dc dq. That's the same thing. And economists like to call it MC, marginal cost. So all three things are mean exactly the same thing. It just depends what the application is and who's saying it. And what are we seeing? So what are we seeing? We're seeing, so what can you tell me about marginal cost? So when I ask you a question about a derivative, the first thing you always think about, is it increasing or is it decreasing? Is it positive or is it negative? So what can you tell me about marginal cost? It's positive. Okay, that makes sense, right? Because it costs something actually to produce things. What about the second derivative? Well, here we actually see that it changes over time, right? So here, it's concave down, it's negative. Why is it concave down? Economies of scale. Okay. So C double prime. Up here, C double prime is positive. What is that a sign of? That's a sign that economies of scale are over and we're having to increase whatever. Okay, so you actually see that the math and the economics actually sort of go hand in glove. So you can actually say economic statements in math terms, and math terms mean economic statements. Okay, so understand this, you actually know some sophisticated economics, and it's just using calculus to describe things. Okay, let's see, I've got room here. Well, you can do the same thing for revenue. Okay, now, typically there's no fixed revenue, so the intercept is going to be here. And we're going to have R prime is the same thing as dr dq, the same thing as marginal revenue. What do you expect marginal revenue to be? Positive or negative? Negative? Positive, right? You expect it to be positive, like you sell stuff, you expect to get money. Okay, and so what we expect is to be like this, and the curve maybe to look a little bit like this. Okay, so we expect R prime to be positive because we're selling our stuff for money, and we're getting money. And what about the second derivative of revenue? That is negative, right? And that's also understandable from an economics point of view, right? Because you glut the market, you put, if you want to keep on selling your goods, if there's too many goods in the market, then you have to lower the price to be able to sell that. Again, that kind of makes economic sense. And we can actually put the two curves together, and we could get something like, maybe we could get something that kind of looks like this. And here is our break-even point. And so if this is R and this is C, that's the end of profits, doesn't really have a name. What's the significance of that region?
It's the maximum profit.
It's not the maximal profit. What kind of profits are being made here? A profit. What kind of profits are made here? What do you call those kind of profits?
Losses.
Losses. Right, here's losses. Here's actual real profits. So profits are positive, and over here profits are negative. So that's actually we call them losses. And so the maximal profit is somewhere around here, right?
That's the maximum margin, but wouldn't it be the maximum total where they meet?
No, because remember, where they meet, that's where revenue equals costs. So if revenue equals cost, how much profit are you making?
But if you're producing at the second or point where they meet, you're still getting all the profits of that, the rest of that middle section.
But here,
Getting closer to it.
this thing here, this distance here is revenue minus cost. That is profit. So the distance between the two is the profit. So you want that to be the greatest. You want the R to be well above the C. That's when you're making a good profit. When R equals C, that's when you break even. That's when revenue equals costs and you're just getting by. And then you increase and then you make a profit. And at some point, you're going to make your maximal profit. That make sense?
Sort of.
And then if we were to actually make a little graph down here of profit, what would it look like? So down here it's negative. Here's our break-even point. Here's the other point here. Here it's negative here, so it's kind of like negative there, negative there. And up here, it kind of looks like that, right? Where this point here corresponds to this maximal here. Okay? And so we can talk about the derivative of the profit function. That's the same thing as d pi dq, and that's the same thing as marginal profit. Okay, so what can you tell me about profit? What can we tell me about this? What can you tell me about the derivative of the profit curve? Let's call this point Q star. What happens if Q is less than Q star? What is the sign of the profit function of marginal? What is marginal profit? Is it positive or negative?
Or positive.
It's positive, right? Because the profit is increasing. So what about over here when Q is greater than Q star?
Negative.
Negative. So we don't like that. So this is a very typical business situation where if this was always the case, what would you do if you were a business? You start off, you start producing goods at a point, you break even, and your life is good. And as long as pi prime is positive, what do? You increase production, right? Yeah, you just produce more and more until you reach a point where your marginal profit is zero. Then what should you do? Should you change production then? If you're at this point? If you increase production, your profit will go down. If you decrease production, your profit will go down. So this is the sweet spot.
Well, with the other, your marginal profit's going down, but your total profit's still growing.
No, no. This is the total profit right here. Right? So when it is at its biggest, that is when your profit is at its biggest. Okay? So this is really important. You've got to clear this in your mind. You've got to know the difference between a quantity and its derivative. Right? So typically you want a quantity to be maximized. You want to sit at the top of the mountain. Right? What's that got to do with the derivative? What's the derivative at the top of the mountain? Zero, right? You want to be, because it's flat, right? So once you see that the derivative is zero, that's the sweet spot, right? Because you don't want to go down the mountain. You want to stay at the top of the mountain because that's where you're making the most money. So this kind of marginal analysis is always useful because it's kind of what you do in finance and economics. So, everyone got this? So I can rub it off. Oh. Let's do it. Let's do an example of a question. Here's a graphical question for you. Here's a cost function. So let's actually put numerical values. So 10,000, 10,000, and 1,000, 2,000. And our costs might look something like this. Okay, so that's a typical kind of cost curve. Okay. Kind of question I can ask. Which costs more to produce? The 500th good or the 2,000th good? So this is a trick question, okay? So which unit costs most to produce? The 500th unit or the 2,000th unit? Right, obviously it costs more to produce 2,000 units than 500 units. But is that which is more expensive to produce, the 500th or the 2,000th? 500th, everyone see that? How do you see that?
Because the derivative is higher.
Right. The slope here is steeper than the slope here. Because if you think about what is the marginal cost for producing that 500th good? Well, we can think of that as the cost of producing the 500th good when I write it like this, what kind of formula is this? It's a slope formula, right? So we can see, when we do this little trick, we can see that marginal cost is definitely a slope. This slope is steeper than that slope, so therefore the 500th unit costs more than the 2000th unit. Which costs more to produce, the 3000th unit or the 4000th unit? 4000, right? Because it's getting steeper. Again, get a little slope here. Little slope here. Those are the marginal costs. We see that that is steeper than that. So marginal cost at 4,000 is greater than the marginal cost at 3,000. And of course, the cost at 4,000 is greater than the cost at 3,000. This is true because this slope is steeper than this slope. This is true because this quantity here, this length here, is greater than that length there. Okay, so this is one thing. Okay, a quantity is the height. The derivative is the slope. And the second derivative is the concavity. Okay, there's going to be lots of questions about that. Where is marginal cost the lowest? Exactly, this inflection point here, it looks like to be around here maybe. So that's maybe 2,200. Yeah, that's the inflection point where it starts to go from concave down to concave up. Right, so the marginal cost is decreasing, 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 then increasing, increasing, increasing. So that there is the sweet spot where the marginal cost. Businesses don't really worry about marginal cost. What are they most interested in? Profit. Profit is always the thing that is guiding the business. So you might not care, might not mind to be out here as long as the revenue makes up for it. So that's that. So let's say we're just looking at a piece of the cost curve now. We've got the cost curve here, and we've got the revenue curve here, and we're at this point here. What should the firm do? Should the firm increase production? So yes, what do you think?
Yeah.
That's true. And why is that?
Because that's when they start to make a profit.
So this is actually the break-even point, right?
Yeah.
And so as we increase production, revenue is going to be sort of greater than cost. Okay? So how can we put this in terms of marginal revenue and marginal cost? So what happens when marginal revenue is greater than marginal cost? What should you do? Should increase. And why is that? Right, because if marginal revenue is greater than marginal cost, what is positive? Not profit, because remember, profit is the quantity, the total quantity. We're just talking about marginal now. So when we increase thing, what is positive?
Marginal profit.
Marginal profit, exactly. Marginal profit is positive. Okay? Because you might be making a loss at a certain point. So the profit might be negative, but by increasing production, if your marginal profit is positive, that loss will go down and eventually it will turn into an actual profit. Okay? So be careful about mixing up the quantity with its derivative. That's always the problem. What happens if marginal revenue equals marginal cost? What should we do? Should we increase production?
Depends where it's graph.
So if marginal revenue equals marginal cost, what happens when we produce another good? Do we make any money? No, because marginal revenue. So if our marginal revenue is $5 and our marginal cost is $5, we make nothing by increasing a thing, right? It costs us $5 to make that good. We sell it for $5. What's the point? So we should stay. What happens if marginal revenue is less than marginal cost? Should we increase Q? Right, so let's say marginal revenue is $4 and marginal cost is $5. What happens if we make that extra good? We lose $1, right? So we should actually decrease Q. And that's a sign that something's wrong with the market, that we're overproducing, and we should ease back. Okay, so these are graphical problems. Let's have a look at something numerical. Let's say it costs $500 to produce 1,000 items, and the marginal cost is $25. How much does it cost to produce 1,001 items? Approximately.
I don't know what the formula is called. It's like the tangent formula or something.
Yep. So to make 1,001 items, right, it's going to cost us $500 to produce the first 1,000. And then what's it going to cost to produce the next item? $25. So we estimate it's going to cost $525. How much do we estimate it's going to cost to produce, to make 999 items? $475. Right, so this is using this tangent line approximation to do things. What about 1,100 items?